Okay, welcome back to this channel. Now, actually, before this new video that we just uploaded, one thing you should know is that I actually did something on what sketching signal. Now, to amplify our understanding of sketching signal, for me to know whether my those who are subscribed to this channel and those who are watching this channel actually understood what it takes to actually sketch a signal. I'm giving this question more like a giveaway question. Just try it out, and you can comment about it. You can talk about it in the comment section. Now, today we'll be moving on to what? To system. So I'll be telling you that before I continue explaining about system, please, if you have not subscribed, subscribe. If you have not like. If you have not commented, comment now. Sorry, there's nothing like commenting. If you have not comment. If you have not, how should I put it again? If you have not given us if you have not recommended us to your friend who is actually taking this same course, maybe somewhere else, anywhere else, please recommend this channel. We'll be solving questions. We'll just go straight to the point. No stories. Now, let's move on to this. This is system. What's a system? As I've written on this board, I said a system is a mathematical model that describes a physical process and it relates the input signal to the output signal. Oftentimes, our input signal is always called excitation. It's always called excitation, and our output signal is sometimes called our response. Let me say excitation and response are a common language used by people in control engineering. In control engineering, let me explain this. Actually, signal and system is a prerequisite course for anybody who is going to be studying, be it communication engineering or mechatronics, control engineering. So signal and system is like a prerequisite course, is like a foundational course. So using excitation here is a word borrowed from control engineering. So you should know that a system is actually something that actually expresses the whole of what is happening on the inside. By using the input and getting the output. Now, comparing the input to the output, we can now get the model of our system. Now, I've written something here. This is a block diagram. Here we have an excitation, which is E of S, and here we have our output, which is Y of S. Now, inside here we have our G of S, which is the mathematical model or mathematical representation. We can call this the mathematical model or mathematical representation of our system. So we can say that, so it is sufficient to say that G of S is equal to Y of S over E of S, or Y of S over E of S is equal to G of S. And I can call this G of S the transfer function of the system. So again, a system actually describes a physical process by using your input signal and relating it to your output signal. And your input signal, I gave you the common term used in control engineering, which is excitation, and I gave your output signal, which is a common term used in control engineering for your output, is your response. So we'll be moving to type of system, and I'll be giving an example of how you can actually identify and classify any system that is given to you, that this system is actually this kind of, is actually this type, is actually that type. And many various types of systems that we have includes, number one, we have cursor, we have invertible system, we have memory-like system, and we have so much more like that. And I'll continue, and I'll start with what cursor with us. Okay, now I'm going to be starting with different types of system that we have. One of the very type of system that we have is called cursor system. What's a cursor system? A cursor system, they are system whose output is dependent on its past input and its present input. What I'm saying in essence is that is a cursor system is actually, let's say if you have T, where T is equal to T naught. T naught is the time. Now, a cursor system is a cursor system for every T less than or equals to T naught. For every T less than or equals to T naught. T naught is the present time. Now, every past time also that is less than T naught. Then we can have what? A cursor system. That means a cursor system is dependent on what? It's dependent on the past and is also dependent on the present input to produce an output. Now, here is the problems that we have. The problems here is we should show whether the following signal are actually causal or they are not. Now, let's start with this. Y of t. Now, y of t is equal to x of 2t. Now, before I start solving this, I would like to advise you to understand how you can actually classify a system, whether it is a causal, whether be it causal, memoryless, invertible, stable, deterministic, deterministic system. All you just have to know is this: you have to brush up your linear algebra, because actually we will be employing a little bit of linear algebra here. Now look at this. I have y of t. Now back to the question. I have y of t, which is equal to what? X of 2t. Now let me do some iteration. Like, let me just test this. When t is equal to 1, what did I have here? I have y of 1 is equal to what? X of what? 2 times 1, which is x of 2. When t is equal to 2, look at this. I have y of 2 is equal to what? X of 2 times 2, which is equal to what? X of 4. What this is trying to tell me is this: for me to get an output, at the second time, I need to know the value of x at let me say the fourth period, or let me say 4 seconds, and that is actually telling you what? That is actually futuristic. That means this signal s of t is actually futuristic. Hence, it is not causal. Hence, y of t is equal to x of 2t is not causal. Let me explain again. When I test this signal with when t is equal to 1, that means when we have s is equal to 2, that means before I can get an output of this signal for the first input, I must have waited for me to have gotten what? Another signal, the second signal, before I can get the first signal. The first signal as an output. That means this must have been excited twice. Hence, this is futuristic. That is, I need to get x of 2 to get y of 1. And this is 2 periods. That means I must have gotten about 2 periods. So before my first output will ever appear. Hence, this is actually non-causal, because a causal system depends on the past and it depends on the present. And it depends on the present what? It depends on the present input. But here, this is what? A future input. Before I can get what? A present output. A causal system produces a present output by actually working on what? On the past output and on the present output. A similar, let me say, an example, a real life example of a causal system actually is actually your codec. Your codec contains what? A decoder and what? And an encoder. So before it can decode anything, it has to encode, then decode. That means it is not futuristic. So now let's move to the second problem. The second problem is this. The second problem is in discrete. It simply means sigma n as k is equal to what? Minus infinity. Then I have x of k. Let me tell you this, you don't have to waste your time. Since this is starting from what? K is equal to minus infinity. Since the period of the signal of the system is defined to start at k equals minus infinity. K equals minus infinity is telling you past input. Hence, it still fits into our definition of what? Causal system, which actually states that a causal system is a system whose output is dependent on its present input and past inputs. So k is equal to minus, since this is starting at k is equal to minus infinity. Hence, y of n is a causal system, and Y of t is non-cosa. So moving on from here, we are going to be talking about the next type, which is going to be dealing with what? Memoryless system. Memoryless system. What is really a memoryless system? You will get to know that. I will write the definition. You will see what a memoryless system is. Quintessentially, a memoryless system is a system that you will only see the input after you have applied what you have applied the after you will only see the output after you have applied the input. I repeat again, you only see an output after you have applied what? The input. As you are applying the input, you are seeing the output. That is, a memoryless system is a system that is dependent on its present input, no past. That's the difference between cosa system and a memoryless system. A memoryless system does not need its past to actually produce an output. It only needs to be fed what? An excitation in the present to give what? A present output. So we'll move down to that place. We'll move down to that. Please subscribe, like, comment, discuss even in the comment section. Thank you. Okay, now we are at the second part, which is what? Type of system, memoryless system. A memoryless system depends on its present input to produce what? A present output. That is, now let me quickly state a warning here. All memoryless systems are cosa, but the converse is not true. What do I mean? What I mean by the converse is not true is this. All memoryless systems are cosa, but not all cosa systems are memoryless. I've just stated that clearly. Should I repeat that? All memoryless systems are cosa, but not all cosa systems are memoryless. That is why a cosa system depends on its past and its present to produce an output. But a memoryless system is just like a basket. You pour water to it, that water pours out. So it's more like what? It's more like a buffer. It's more like a buffer. It's copy. Don't let me use that. But it's working like a buffer. It's copy. That is, a buffer is actually a logic device that copy its input to its output. So that is a simple explanation I can give to what? To memoryless system. Okay, all right. Now I'm going to solve this question. Y of t is equals to 2 plus sine t of x of t. Now let's move on. If I said this, let me start by saying y of 1. Let me start by saying when t is equals to 1, t equals 1. I have 2 plus sine t bracket what? X of 1. Let me say this. You might actually, for someone who might actually be looking at this, you might actually think, okay, this is just ordinary mathematics. I should have put wherever I see t, I should have put 1. That is not true. That's why I said you need to understand not just mathematics, but on the brush up on your what? On your linear algebra. Y of 1, 2 plus sine t, x of 1. Now let's move on. Let me try when t equals 2, I have y of 2 is equals to 2 plus sine t, x of 2. Then if I move it to what? Y of k. Y of k, what I will have is 2 plus sine t, x of k. Now look at this. Look at this. What it is actually telling you and what it is actually giving as a report is this. Whenever I need an output at the time k, I need to depend on what? An input at the time k. When I need an output at 2 period, I need to depend on what? An input at what? 2 period. I need an input at the first period, I need to depend on what? An input in the first period. So I can say this system is actually number 1, cosa, number 2, it is memoryless. Up next, I'm going to be teaching on invertible system. Okay, now I'm going to be talking about invertible system. What are invertible systems? What does it mean to have a system that can be inverted? An invertible system is a system in whose input and its output relationship forms an identity. Let me repeat. When you have the input to a system and the output of a system, when they form an identity, that is when we have what? A system that can be inverted. What do I mean by that? See, a ripple of what we know in our basic, actually, let me say, this is Nigeria. Here we are in Nigeria, and one thing is very common that a Nigerian student actually do. Some Nigerian students actually offers further mathematics in their secondary schools. So, or you might call it advanced mathematics anywhere else in the world where you are watching this. But now, there is something that is being taught then called binary operation. A ripple of your binary operation is seen in your signals and system. That is, you know, from your binary operation, when you have, look at this, under binary operation, when you have, let's say you define A, if I multiply A with A minus 1, it's supposed to give me what? E, where E is my what? Identity element. So, it's the same thing we are talking about when we say the input and the output actually forms what? An identity. They have an identity relationship. Now let's move on. Let me explain. This is a question to illustrate my point. Y of t is equal to dx over dt. Notice something. My y of t is equal to is a differential of my what? Of my x of t. That now simply means, and there is no constant added. So that simply means that I can, you know, from your mathematics, I can integrate this. If I want to invert this system, all that I have to do is what? I integrate this side. If I integrate this side, I get x of t. Then I will do what? I will differentiate this side. Then I will get what? My invertible system. Now look at this. Let me explain this. I have y of t is equal to dx of t dt, or written as d dt of x of t. This is y of t. If I want to invert this system, all that I have to do is what? Integrate this. If I integrate both sides, I have y of t dt is equal to what? Is equal to x of t. Is equal to x of t. Therefore, I can say x of t is now equal to what? Integration of what? Y of t dt. You know, a differential operation and an integration operation, they are one and opposite. So now this is my new system. And I got this my new system from my what? From my old system. My old system defines y of t to be what? The x of t dt. And my new system defines it to be what? X of t is equal to y of t dt. So this is actually telling you this is actually the opposite of this. Hence, this and this system 1 and system 2, they are still the same system, but what you have actually explained here is that these systems are invertible. So in a case like this, let's say you have y of t is equal to dx of t dt plus k. I'll be closing this video by giving you this, that if you have a system like this, will this system be invertible or will it not be invertible? So you tell me in the comment section whether this system is invertible or is not invertible. So thank you for your time, and please do subscribe, like, and recommend the channel to a friend. Let it pop up in different people's channel from different university. This channel is not being monetized. Please try as much as possible to subscribe, like, and comment. Thank you very much.